what we're going to do first is we're just going to practice what you guys spoke about on Monday. So like we've done every lesson, just 3 quick questions to practice. I'm going to do the first one with you, and then I'll give you some to try by yourselves. So on Monday, you spoke about the distributive law, and the distributive law tells us that when we have an exponent outside our bracket, we need to multiply it to every exponent inside the bracket. Okay. Now what we need to, what we need to remember is that everything inside our bracket does have an exponent. So this 3, this coefficient of 3 over there does actually have a 1. And so when I distribute, when I multiply my exponent 3 into my bracket, it's not only going to be multiplied to the 8, it is also going to be multiplied to this exponent of 3. Another way to think about this, although I don't recommend doing this, just because it takes a bit of time, is for you to see that because you are cubing a bracket, what you are doing here is you are multiplying this bracket 3 times. So you've got 3x to the power 8 times 3x to the power 8. And I've obviously made some weird choices here, so let's try and move down a line. 3x to the power 8, 3x to the power 8, 3x to the power 8. Now, the reason I'm saying don't expand is just because if that exponent outside your bracket is like 20, you don't want to write 20 brackets, but it is a way to hopefully understand the distributive law. So now we want to go and multiply those exponents. Excuse me. So what we're going to do is we're going to multiply, and you don't need to write the step down. Sorry, guys, I don't know what's happening. You don't need to write the step down. I'm going to show you the multiplication. So we've got 3 to the power 1 times 3. And x to the power 8 times 3. Remember, distributive law, we multiply the exponents. That then leaves me with 3 to the power 3 and x to the power x to the power 24, because 8 times 3 is 24. Now, guys, remember, 3 cubed is saying 3 times 3 times 3. So 3 times 3 is 9, but we still have to times it by another 3. And 9 times 3 gives us 27. And so this answer here is 27x to the power 4. We have distributed our exponents and we have simplified our expression. Excuse me. So when distributing, we need to multiply our exponents. Okay, Watobe, you're not dumb at all. It's a very common mistake to make. Just remember, when working with exponents, we always only work with exponents. So what I mean by that is you can't multiply an exponent and a coefficient. You would have to multiply an exponent and an exponent together. And because this original 3 is a coefficient, we can't multiply it with an exponent of 3. Okay, so common mistake to make, completely understand that. Sorry, guys, clearly this is not my day. Completely common mistake. It does happen, but just remember we are multiplying exponents. And what I'm actually going to do is I'm going to make a little note for us here. So distributive law is multiplying exponents. Alrighty, so I want you guys to try. I want you to try that one. No, let's do question 2 together. Actually, no, you can try question 2. I think you can all give it a go. You've done this already. If you're struggling, again, remember that what we are doing is we are multiplying our exponents. So everything inside your bracket has an exponent, every single thing. So this 2 has an exponent, the x has an exponent of 2, and the y has an exponent of 2. So this exponent of 9 must be multiplied to every single exponent inside our brackets. Right, so give it a try. Guys, remember, if you have questions, put them on the chat and we will help you. This is all revision from Monday, so there shouldn't be any questions. And if you are feeling confused, like I said, or like Yolanda said, we record all of our lessons. So that means that you need to go and get Monday's lesson off Watobe's website, and you need to watch it so that you hopefully refresh what was going on Monday with the distributive law. Can't speak today, apparently can't write today. It's really Wednesday. Right, remember answers, you can put them in the chat. I know a fraction does become a bit tricky, but when you type your answers, remember a fraction, you can just use the hash sign when typing. Once again, if you are new, you need to go and watch the videos that we have on Watobe's website to catch up. We have essentially done most of this. And if you are feeling lost, even if you're not new, you need to go and watch those videos. So the link to watch the videos is essentially just watobe.com. Oh, there we go. Leonenda's on it. Okay, guys, I've told you what to do. So all you need to do is follow the instruction that I've given you.
Just another thing, my people, that is gonna help you quite a lot. So if you see you're lost and maybe you are not following in a way, you can wait for us to do more examples and then you can follow. Or you can ask on the chat exactly which steps are you lost at, okay? So you give it a try, just like Teacher Sam is explaining. And I know that some of you just join now and then you look at this and you just panic. So please do not panic. We will do at least more examples, but remember that we have done this lesson on Monday, okay? And it's all recorded, okay, my people?
Okay, so guys, I think that's the really important thing here. Like the fact that it is all recorded and the fact that this lesson has already been done, you guys should know what's going on here. And if you don't, you need to go and watch the video. Okay, so I'm going to go through this because I see our variable exponents are looking quite good, but our numbers looking a bit strange. So remember I said we multiply the exponent outside, so that 9, with all of our exponents inside. So for the 2, we've got 2 to the power of 1 times 9. For the x, we've got x to the power 2 times 9. And for the y, in our denominator, we've got y to the power 5 times 9. Sorry, I'm going to move my cat now. So that is how you apply, sorry, baby. That's how you apply the distributive law. You need to multiply your exponent. Once you've done that, you can now simplify. So now we've got 2 to the power 9, because 1 times 9 is 9. X to the power 18, because 2 times 9 is 18. And y to the power 45, because 5 times 9 is 45. Now remember, 2 times 9 is 2 times 2 times 2 times 2, all the way 9 times. All right? So that actually means that we have got, I'm just going to go here, 512 x to the power 18 all over y to the power 45. So you need to multiply your exponents using your distributive law, and you can simplify your numbers, so the 2 to the power 9 if you want. You don't have to, but it does make a little bit more sense. I prefer writing the number. I feel like I understand a number better than an exponent sometimes. So we have 512x to the power 18, y to the power 45. You are just multiplying your exponents. Okay, based on this, I'm going to do the last one with you. I will make all of this smaller for you to take screenshots. Okay, so I'm actually just going to take off this -3. We're going to ignore that right now. All we want to do is we want to distribute this 3 into our bracket. Okay, so we're going to have x to the power 3 times 3, y to the power 5 times 3, and z to the power 8 times 3. We are distributing, we are multiplying exponents. So x to the power 3 times 3 becomes x to the power 9. Y to the power 5 times 3 becomes y to the power 15. And z to the power 8 times 3 becomes z to the power 24. Now, if we had kept the 3 there, just so that you understand what's going on, English. If we had kept the 3 there, what you need to be careful of is the 3 is not inside the bracket. So when I distribute, I'm still only distributing this outside exponent to the exponents inside the bracket. This exponent applies to your bracket only. And so we will do our distribution in the same way we did this, but we will just keep the -3 in front. So this will be x to the power 3 times 3, y to the power 5 times 5, and z to the power 8 times 3. So it's the same as what we did there in blue, but now we've just got that coefficient. And so we end up with the same exponents for our variables. We just still have that coefficient in front. All right, so guys, that is the distributive law. That is all done. You have done this lesson, which means that if you are feeling uncertain, if you are feeling a little bit lost, you need to go and watch Monday's lesson. Okay, I completely understand. And I'm just going to take a second here because people are distracted and we can't be distracted. If you are going to be distracted, then maybe it's best that you take a second and refocus. If you are feeling lost, all of the videos from term 1 and now term 2 are on the website. Yolanda has put the website link there. You can go back and rewatch every single lesson from the very first day in January. So those of you feeling like you're still struggling with term 1 work, go and watch the videos. They are there for you. If you're struggling with this work that has already been done, go and watch the videos. Unfortunately, we cannot redo an entire lesson. So you need to take the responsibility and go and watch those videos. Yolanda's put with the website there for you again. Excuse me. All right, so if you want to take a screenshot of those 3 questions, there it is. I'll wait for a couple seconds, let you take a screenshot, and then we're going to move on to today's work. We might not have a brain break, but we'll see how we go.
Yeah, we soldier on, my people. Y'all needed to be reminded. So always make sure you're in class, okay? Unless if you're new. And you always need to go and watch what we have done, okay? So you can follow nicely. But let's all focus on what Teacher Sam is about to teach us now. And then after this lesson, please rewatch the video before you attempt the quiz, okay? Rewatch what you have learned on Monday or what you should have learned on Monday, okay, my people? Y'all are doing just fine.
And so I'll be saying yes in answer to your question, yes. But Clylia, no brain break because we've spent too much time doing this. Unfortunately, when we spend time doing things that we shouldn't be doing, it means that we don't get through the lesson. But we will see. Maybe we have time for a brain break. We will see. Okay, so guys, what we're going to chat about today is our final sort of rule that we need to know in exponents, which is the power of 0. Okay, now the power of 0 is quite a cool one. And there's a couple different ways that you can think about this, but hopefully the way I explain it will make sense to everyone and will understand the power of 0. So if we think about just a normal number, if I divided 3 by itself, I'm going to get 1. if I divided negative 21 by itself, I'm going to get 1. And so hopefully what we see here is that anytime we divide a value by itself, we end up with 1. All right. So that's going to help us understand this whole power of 0 situation. So now let's translate this to our exponent and our variable situation. What happens if I had x to the power 3 divided by x to the power 3? Well, if we apply our exponent law tells us to subtract the exponent. So we would have x to the power 3 minus 3. And that would give me x to the power 0, because 3 minus 3 is 0. But what does that actually mean? What does x to the power of 0 actually mean? So if we now take a slightly different view on this, we could also view this as x times x times x, because that's what x to the power 3 is, divided by x times x times x. So we could expand. We know that when we expand, we can cross cancel to simplify. And if I'm canceling everything, all I'm left with is 1. But I know that that is true because I've said when we divide a value by itself, we get 1. And that is exactly what I'm doing here. I'm dividing x cubed by itself. So we know technically that if I'm saying x cubed divided by x cubed, I must get 1. And so what our definition, or what our power of what our power of 0 says to us is that whenever we have, let's pick another color here that's a bit different. Whenever we have a base to the power of 0, we have got a value of 1. So that is our rule that we need to know. Any base to the power of 0 is 1. Zisma, you can't use 1 instead of 0 because it does mean different things. An exponent of 1 and an exponent of 0 means 2 different things. So if you're saying that any time you see an exponent of 0, you write 1, that's okay. But you need to know that x to the power 1 is not the same as x to the power of 0, because x to the power of 1 is x and x to the power of 0 is 1. Those are 2 different things. Right, so guys, essentially exactly as Sia said there, if a number has an exponent of 0 or a power of 0, it becomes 1. That is our rule. All right, so we need to be able to apply this in different examples. And this comes from the fact that a value divided by itself is 1. And that's essentially what a power of 0 is, because we know that when we subtract exponents, if I say a value minus itself, we're going to get 0. Alexa, you mamming me? Do we have a question? You can pop it there on the chat. Right, I'm just waiting for everyone to take a screenshot of this, those who want. And then we're going to have a look at examples. Cool, no problem. So 0 does always become 1. Guys, hands when I ask for hands. Letu, what's wrong?
Hello?
Yes?
I was asking, do you write the base when you write the answer for the power of 0?
So you don't have to write the base x and then the power of 0. You are going to write 1. So you automatically write 1.
Oh, okay.
Okay. Alrighty, guys, so let's have a look at some examples here. So our very first one is x to the power of 6 to the power of 0. Now, what we need to remember is that we've got the distributive law. So let's apply the laws that we know. The distributive law tells me that I need to multiply the exponent of 0 with the exponent of 6. So that gives me x to the power 6 times 0. But we know that 0 times anything is 0. And so what I actually have here is x to the power 0. And so this is now what I was saying. X to the power of 0 is not as simple as it can get. We know, because we've looked at our law, that x to the power of 0 is actually 1. And so our final simplified answer here is just 1. Sorry, that is wrong. Guys, your answer is not 0. Your answer is 1. Your exponent is 0, but the value of something to the power of 0 is 1. 6 times 0 is 0, which means that because we've got x to the power of 0, we have got 1. Essentially, what this is saying is x to the power 6 divided by x to the power 6. Okay, grade 8, I'm not too sure what's happening tonight. I don't know if we've just had a distracted day, but some of you are not listening. And for me to keep repeating myself becomes a problem. So I'm going to say this one more time. We distribute the 0 to the 6. So it becomes x to the power 6 times 0. That is the distributive law. We've done examples of it. You had an entire lesson of that on Monday. We know that. If you don't know that, watch the videos. 6 times 0. 0 times anything is 0. So 6 times 0 is 0. What that means is that we end up with x to the power 0. Now we know, because we've just done it, that any value to the power of 0 is 1. That was the law that we just did. So now that I've got this x to the power of 0, I know that x to the power of 0 is actually 1. And so my final answer is 1. It is not x to the power of 0. It is not x to the power of 1. It is 1. All right. So please, we need to focus. We need to listen. Otherwise, I'm just going to keep repeating myself, and that becomes a little bit irrelevant. Right, and clearly a really good explanation there of the difference of powers of zeros and powers of 1. Very nice. If anyone wants to see that, Butlale has put it on the chat, but basically, if you have a variable with no power written above it, it does actually have a power of 1. We just don't write it, so it's an invisible one. But if it's x to the power of 0, like we have here, it is 1. All right, let's have a look at a second example. I'll make it smaller in a second or two for you to screenshot. If we now have a look at this example, again, what we want to do is we want to apply our distributive law. The second we see a bracket to the power of something, we distribute. So that means I need to distribute this 0 outside to the 4, to the 4. And remember, this 2 does have an exponent of 1. That's what Botlale just said. If there is no exponent, there's that invisible exponent of 1. And so we also need to distribute that to the exponent of 2. What that means is we now have a situation of 2 to the power 1 times 0, x to the power 4 times 0, and y to the power 4 times 0. What that means is anything times 0 is 0, remember, is that we've got 2 to the power of 0, x to the power of 0, and y to the power of 0. But we know that when we've got a value to the power of 0, we have 1. So this 2 to the power of 0 is actually a 1. This x to the power of 0 is actually a 1. This y to the power of 0 is actually a 1. And so what we have here is 1 times 1 times 1, which is just 1. All right, so because that whole bracket was to the power of 0, every single thing inside that bracket has to have 0 distributed to it. And so that's why all of the exponents end up as 0, and why we end up with a final answer of 1. So I'm just going to rewrite our law for ourselves just in case. So any value, oh, come on. Sorry, I don't know what's happening. Nope. Okay, cool. Maybe I'm not writing anything for us. Fine, I'll type it. Any value to the power of 0 is 1.
Okay, my people, we got this.
I don't know what's happening. Okay. Right, so I'm going to make this a bit smaller for you to take a screenshot. If you don't know how to take a screenshot, just use your cell phone, take a picture. Right, so I'm waiting for people to take screenshots here.
Cool, my people, step by step. Y'all are doing good.
Right, if you have questions, ask your questions now, so you can raise your hand if you want. I'm going to be honest, I don't understand what you mean. Just tab the pens and you're done. I don't understand, so help me out there.
Aurelo, raise your hand. You must find a reaction button on your device. Click on the raised of hand. You will see a hand that is up and you just click on it. So you can ask.
Yeah, I don't really know what 116 means.
Yeah, I'm not quite sure what's going on today, guys.
Okay, so question in the chat. No one's raised their hand. Okay, Alexa, question. Right, okay. Solfelo? Oh, no, sorry, I muted you again. You're going to have to.
Yeah, ma'am. So like if if the value, ma'am, it's over 0, let's say it's 1, so then the number, yeah, the number goes up or it also stays 1.
Can you give me an example?
Ma'am, let's say it's 4 over 1, and yeah, so ma'am,
12 over 1, yeah?
4 over 1.
And
Over
then?
4 over 1, ma'am. So does it go up or it just remains 1 or 4?
Are you saying 12 or are you saying 4? Sorry, 4 over 1. Your
Yes,
headphones,
ma'am, let me just type it.
your voice is too, your headphone thing is too far away from your mouth. I can't actually hear you very well. But
Ma'am,
yes, if you
I'll just
there we
type
go.
it down.
Okay, I can hear you much better now, if that helps.
Okay, ma'am. So it's 4-1 over 4-1.
Okay. Yeah. Like that. Or with
No,
as
ma'am, not
expression.
41. Not
So
41.
like this. Like this.
Yes, ma'am.
Okay. Yeah.
Yes, ma'am. But it's as a fraction, the way you did in the example.
Okay.
Yes, ma'am. So then does the value of the 4 go up or decrease?
Well, no, because what you're doing here is you're dividing something by itself. So this is just going to be equal to 1, because if you divide something by itself, it's always 1.
Okay, ma'am. That's all I wanted to say.
Okay. Cool. Well done. No, it's not anyone's day. We're all on the same page. I'm glad we're all in the same boat. We saw a question. Who you saw? Also, someone isn't on mute. Let's remember to mute ourselves, please. No. Okay. Righto. So, guys, I want you to. Okay. I want you to try C. I'm just changing it a bit there. Right. So I want you to try C for me. Give it a go. You've taken screenshots, hopefully.
Remember to put answers on the charts. When you get your answer, you can put your answer on the chart, okay? We see you, Alicia, Nelson, we see you, Masejo, we see you. Lunati, Gift, nice guys. Taylor, Lali, nice everybody. Well done.
Good, guys. Okay, so exactly. Oh, come on. Why do you hate me? So if we are going to distribute our 0, okay. Not going to fight it because it's just going to end up annoying me and then I'm going to get frustrated. So let's just do the best we can. I need to distribute this 0 to this exponent of y, which is 1, to this exponent of 3, and to the exponent of this coefficient 3, which remember is 1. All right, so what that means is I am going to end up, did I not say I wasn't going to get frustrated? And now I'm getting frustrated. Okay, so what that means is I'm going to end up with, me and technology today, I'm going to throw something. All right, I'm calm. 3 to the power 0, x to the power 3 times 0, which is actually just 0, and we know that. Let's just go 0, and y to the power 0. Now, if everything is to the power 0, like we saw in the last example, what I have is 1. Okay, so because all of those have an exponent of 0, I am just working with a value of 1. I wish I could tell you what's happening in my life, but it's not. All right, so I want us to try the example that I initially had here. So I'm going to call this D, which was something like, I'm just going to make a new one up. Right. I'm not going to cry. I'm not going to cry. Everything's fine. Everything is fine.
Just that we're getting there. We get there. There we go. This one. Number D, everyone. Let's go.
Thank heavens for Yolanda, because I think I would have cried and just logged off a long time ago. Okay. Try D for me. What I need you to notice is the fact that this -2 is not in the bracket. So that means it cannot be affected by that exponent of 0.
Let's go. Give it a try, my people. We can do this. For this one, can we, Teacher Sam, is it okay if we can have someone to explain this one when they are all done?
Absolutely.
Nice. The guys, y'all can just put on the chat when you're done, just say done. We don't put an answer, just put done, okay? And then when we see that y'all have a lot of people have said done, we want one person to raise their hand to give us an answer, okay? So everyone who's done, just put done. Okay, y'all, just say done. We are 98 of us. Let's just concentrate. You are writing down on your book. There we go. There we go. So we are all done, right, my people? Nice, guys. So now can we have the hands on the chat, please? Hands on the chat. Let's see who we haven't talked to. Let's see. Let's see. Hands on the chat. Y'all, we're saying you're done. So whoever is done, put your hands on the thingy, on the, raise your hand so that we can choose. Okay. Teacher Sam, which one do you think we should communicate with? Who's our lucky winner?
Okay, let's see. I appreciate you telling me not to cry, guys. I appreciate that. I'm gonna try not to cry. Nelson looks keen.
Nice. Nelson, your turn. Teach us, Nelson. How would you do this question?
So, what I did first was I took the 3,
Okay.
and since there's an exponent 1 on top, I said 1 times 0, which gave me 0.
Good.
Then I did the exponent of x, which was 2. So I said
Yeah.
2 times 0 give me 0.
Good.
Then I said y. The exponent of y was 6, so I said 6 times 0 give me 0.
Good.
So the next thing I did, I added the negative. I just left the -2 in the same place. Then I put the columns for the ones, because
So like that.
yes.
Good.
The next I said -2 with the power of 1.
Okay. And was that your final answer?
Which gave me a -2 as the answer.
Good. Well done. Excellent, Nelson. Thank you.
Thank you,
Nice.
ma'am.
Nice, guys. So I hope everyone has corrected. Y'all can lower your hand, please. Well done, my people. I'm so proud of you. Well done.
Nice,
Lower your
Nelson. Okay, so guys, the difference here was because we had that coefficient, we need to bear in mind that it is not being affected by that power of 0. And so what we saw here was that the whole bracket became 1 because all of these had a power of 0. So they all became 1. And -2 times 1 times 1, I can times that by 1 as many times as I want. I'm still going to be left with -2. And so that is our final answer. All right. So remember that when there is a coefficient to the bracket, so when there's a number sitting in front of the bracket, it is not being affected by the exponent. So we just leave it there, exactly as Nelson said. Leave it there until you've sorted out the whole bracket, and then you can deal with it. Yo, not my day. We're getting there, guys. Thank you for being patient with me. All right. So I think time for a screenshot. I don't actually even know what we've screenshotted. That's where I'm at. All right, so screenshots, A, B, C, D.
that. No brain break. Apparently, y'all need more exercises. Okay, y'all can do this.
So I'm just waiting for you guys to take screenshots here.
Okay.
Alrighty, guys. So there's just one more thing I want to chat about. This is obviously now example E because I've given you another example. One thing I want to chat about is when we have a situation where there's no bracket. So here we can see that we've got no brackets in this situation that we have going on here. So what we need to remember is that this exponent of 0 only applies to the base that it is attached to. Oh, come on, you're doing well. Right, it only applies to that x. If there's a bracket, then we would distribute. But because there's no bracket here, I cannot apply that 0 to the -2 there because it isn't being affected by that exponent. So what that means is much like what we had now in the last question, we're still going to have the -2, but we know that that x to the power of 0 becomes 1. And as I've just explained, -2 times 1 is -2. So this x to the power of 0, that whole situation over there, because it was only the x to the power of 0, only that became 1. And so we could then simplify our answer. Excuse me. So when there is no bracket, so you can see the difference between C, D, and then E. Here we had brackets where we had to distribute. Now in E, there's no bracket, so there's no distribution, and so that exponent of 0 only applies to its base. It only applies to the x. All right. So what I want you to try now, also my numbering's just gone weird. We're just gonna roll with it, guys. Everything's fine. This should be F. It's apparently A. Please don't fight with me because we will have a problem. Woo! Right, English. Try F for me, and then I think we're gonna call it because here we are.
Yes, the last question of the day, my people. Give it a try, give it your best shot. Let's see. I hope everybody gets this one correct. Okay, so again, if you're done, please say done on the chat. Okay, so let's do it as fast as we can, and don't write your answers on the chat. Just say done so we can see that you are done. We can do this, my people. Nice. Blessing is done. Who else is done? Lisedi, do the question. Botlali, give it a try. We will do corrections, guys. Don't panic. Okay. Most of you are done. I'm getting there. I'm giving you another 1 minute or two. Let's do this, my people. We are giving it a try, okay? On your books, give it a try. And when you're done, just say done. Okay? Nice job. Okay, now raise of a hand quickly. Let's see who's gonna give us some answers.
Alicia was the first one. If we want to just go with first hand up.
Nice. Alicia, we are all yours. Teachers, everybody, we are listening and doing corrections, okay?
Alicia, there should be a pop-up to unmute yourself. There we go.
Ma'am, can you hear me?
Yes.
Okay, ma'am. So you leave the 3 by itself.
Good.
And then you say the x to the power of 0 equals 1.
Good.
Then you leave the y to the power of 2 and the z.
Good. So what is that?
It will equal
What?
to y3 to y 3y to the power of 2 and z.
Oh, golly, thank you. I appreciate the giggle because I'm there. All right, so guys, exactly. Once again, it is only this x that has the power of 0. There is no bracket, so there is no distribution. So it is only that x to the power of 0 that becomes 1. As Alicia said, everything else stays exactly as it is. It's not been affected in any way. It stays exactly the same. And so it is only that x to the power of 0 that becomes 1. 3 times 1 is still 3, so we've got 3y squared z. Right, and that is where I'm done.
Nice. There we go. So hopefully y'all learned, but please ensure that you repeat the lessons before you do that quiz, okay? Because y'all was struggling a little bit, but you did the best, okay? And teacher Sam and I gotta love and leave you, and